Hi everyone. First of all, I would like to thank the organizer for KIT 2026 for inviting me to speak at this event, and also thank for all of you for being here. So today I will talk about what changed when security practice met in blockchain. Like I want to focus on security, not talk about like token or the future of finance. So let's move to my outline. So the first part I will there are four parts. The first is the overview of my speech. The second one is what actually changed in security. And the last one is real incident, why like project lost 1,000 or even like million of dollar. So the first one, the immutable nature of blockchain. Like blockchain, like as you know, blockchain has four like main attributes. The first one is the decentralized. The second one is distribute. The third is like the immutable, and the last one is consensus. And the immutability's attribute change how we like think security in blockchain. So why? Because like for example, when you want to like buy a ticket in a hotel or buy a ticket or book a hotel, all your transaction, if you interact in blockchain, will record permanently, and it got changed forever. That is why like when you deploy your product on blockchain, you cannot change logic anymore. So the next one is like the shadow security assumption. Well, at first when I was in university, I planned to become like a backend engineer. I never imagined that in the future I will work in blockchain field. And like as I remember, in my third year study, my friend invited me to the blockchain class, and I I joined. And after that, I was surprised. Like everything, like from the background security in the backend, like changed immediately, and I have to like change what I think, what I what I think about the security in blockchain. I have to rethink. So the next is like the familiar world of Web 2 security. Like in the like Web 2 platform, we trusted admin. Like we have like the like centralized server that ensure like all the data is managed in the like our environment, and also like for example, uh, with Web 2 project, we have a server, and also like um, there are the admin can access to your server to probably sometimes they can like manipulate the data or like update the user data, and no one can like control that. So moving to the second part, what actually changed in blockchain. So I will talk a little bit about like the change in the trust model, the change in ownership, and the last one is the execution layer change. So first, the change in trust model. Let's say in traditional security, we have like the infrastructure, the internal team, and the admin, and like all of this thing is centralized, and like anyone in the like internal team can like manipulate this kind of thing. But when it comes to blockchain approach, code is law and code is public in blockchain, and everyone can read your code, and they like the user who like use the blockchain product, they will know like where their money. I'm sorry. Like when it comes to blockchain approach, when user use our product, they will know where their fund will go. Like they will know like how our this functionality will work because all the code is public. So moving to the next, change in ownership model. So in the traditional security, we have the old, like each project have database, and also I know that the database is managed by the internal team, and also no one can control like who will accept. I mean, no one can control who have the ownership. They access to the database and they change their like balance in their account. For example, let's say in the like of a website for like allow for like for example buy tickets for planes. They if the like admin access the database, and they manipulate their data to, let's say, increase their balance. So no one can control that. But in blockchain, like you can see here, each user, like they own their own private key. Like you can imagine that, for example, let's say, with your account, no one can access or adjust your data, because only the person who owns the private key can like interact with your account. And also that means that no one like admin a project or like anyone who have ownership can like adjust like user data. And also let's say the reverse, no one can, like when I buy a ticket, I want to like roll back my transaction, but in blockchain it say no. After you make any action, no one can change your action. So the next one is execution model change. Like I created a like basic diagram here, so I will explain a little bit. In traditional system, user go to our product, and then they like interact with our product in the front end side, and in the front end side, they will call the API to like interact with the back end side, and then move into the database to like get their information or like do whatever user want. And moving to blockchain, what actually changed? In blockchain, we have the concept of mempool and smart contracts, and also the state machine. So let me take an example. Let's say I would like to like buy a ticket in the Forkit event. Instead of like in blockchain, when I buy a ticket, my action will be stored in the mempool. Like you can imagine a mempool like a place to store the bending action of user, and then the mempool also like include the logic of smart contracts. The smart contract here is like, you can imagine like your code. It is code. like you define, like if for example, you define a ticket price is like $10, and this logic will be stored in this smart contract. And smart contract is immutable because it makes use of blockchain attribute. And then after your transaction in mempool was selected by some, I would say, the operator. And then operator will like verify your transaction and also consensus with other operator to make sure like at least half of operator like verify your transaction. This is what actually changed in the like pipeline of user interaction in blockchain. The next part is a real incident in blockchain. Despite the blockchain attributes such as decentralized, distributed, the next one is immutable, and the last is consensus. Is a blockchain that is the background layer, but in the project, application layer, it still have some security issues that make the project lost 1,000 or even like million USD. So I will take like 5 example, like famous security issues in blockchain. The first is the project name DAO, and the like security issue is called reentrancy attack. And what is reentrancy attack? How it actually work, and how like developer can avoid this kind of mistake in their project. So let's see. You can imagine a reentrancy attack is like the hacker try to like exploit the order of transaction to drain the fund of our system. And I create a like diagram here to explain so how hacker actually exploit this kind of security issues. Let's say the first one is hacker like deposits ETH tokens in our system, and then they make a request of their fund. But let's see. In step 3 and step 2 and step 3, between this step, before our logic in smart contract update the user balance, hacker exploit the the fallback function to like repeatedly drain user fund until like the fund is run out. And this attack is like make use of fallback function. So how to avoid this kind of mistake in the future when you develop your products? So I think with my experience, the first one is like update all the user data before like we make a like important logic such as send fund to like someone else tries to make sure updates all the data. And then the next one is like hiring the like audit firm to like verify your smart contract to make sure that it gone like expose any kind of like security issue like reentrancy attack. So the second use case is some finance with the issue error called routing error. So why blockchain expose like routing error? Like in the blockchain, there was no definition of like decimal number or floating number. Like every division equation will be like floating, like route down. So let me show the detail. For example, I make a division like 10 divide 3. The exact result should be 3.33. But in blockchain, the actually result at the end is 3. So the hacker like make use of this like attribute of this issue to make the exploit. So what is routing error actually work in like solving finance. So for like you can see here like in step 1, 2, and 3, the hacker like the exchange rate between two token was in the slide here. It has to be two some volume, but the result is 1.99. But in blockchain, it will be route down your result, and the actual result is 1. And that's why like hackers try to like exploit it kind of attribute to like exploit your product. So how to like developer avoid this kind of mistake in the future? Definitely the first one is like hiring the third-party audit firm to verify your smart contracts. And the second one is at some point trying to like know this case should be route down or route up, because in blockchain we have the like library to like route down or route up your number, and you have to understand like in this case your like desired result you want need to be route down or route up. The third security error is the sandwich attack. So what is sandwich attack? Let's say like I would like to buy the like sliver, and the current sliver is like the current price of sliver is, let's say for example $1,000. And when user like go to my product, they like expect to buy the sliver price at $1,000, but someone know their action because user like all the transaction of user will be submit into mempool, and the hacker try to like read the mempool, and they make the like first like the front run buy. For example, I know like you want buy like 10 sliver at price $100, and user like go to my platform and buy sliver with price with a high like huge amount of sliver, and then that means the price of sliver will go up. Yeah, the price of sliver will go up, and then the user they want to buy 10 sliver at price $100, have to buy the sliver at the price higher than they expect. And after user they want to buy the sliver at price $100, like execute their action, like the hacker like make the second transaction like sell all the sliver that hacker bought before. That is how sandwich attack work. let me show the detail here. So, yeah, this is the detail of how hacker exploit this issue in sandwich attacks. Instead of like my example, they buy sliver. In blockchain, they buy ETH token. So the next example is the Oracle manipulation. So let's say in blockchain, there's no way for like blockchain to get the real life data, such as get the real price of the sliver or get the result. I mean the let's say the forecast, weather forecast. There's no way to get the real time data from a real life. So that is why Oracle likes coming. But in Oracle field, like there are many types of service they provide their Oracle service. They can use a third-party Oracle, or even they build their own Oracle to create the price between two tokens. And the example I show here is this product choose to build their own Oracle price. So let's see detail. Firstly, the hacker make a flash loan. What is flash loan? Flash loan is I want to make one transaction, like I borrow money and I lend money and then I borrow money seamlessly in one transaction. That is the definition of flash loan. The attacker make a flash loan action to make the Oracle know the action, and then the Oracle automatically calculate the price of token based on the flash loan. It's normally the token price will be inflated, and then that is the hacker manipulate the price. You can see the diagram here. The real price of RapidTC is $10,000, but after attacker make manipulate the token price, it will go up to $15,000, but that is the fake price because it in the flash loan action. And then the protocol because the protocol works around the logic of smart contracts, so the protocol know this action and show this issue, and then the collateral value is time 5 for the real value, and the attacker will borrow and to drain the whole fund in the pool. And how to avoid this kind of issues in the future. So the first one definitely is hiring the audit firm to verify your smart contracts, and the second one is use the decentralized Oracle. They provide their service to provide the real data from the real life. That is what I learned, I experienced through my work in training. And if you we also provide another service, and if you needs or exchange any idea, just contact us. That's all.